All right, so I'm going over questions from 7.2 in the 20-2 workbook. So the first question to go over is 4. So with this type of factoring, what you want to be able to do is basically recognize anytime that you have two terms instead of like the normal 3 that you're used to seeing, like this one. Basically what you want to do is check and see if those two values are perfect squares. So basically if you can square root them to get a whole number. And then if you can, then there's a really easy way to factor it out. So with this one, basically 9, we know we can square root it to 3. X squared, we can square root to x. And 36 square roots to 6. So it's a really good it's good if you kind of know your perfect squares to begin with, but if you see any setup where there's only 2 terms, if you don't know your squares very well, then always just try square rooting them in your calculator if you need to. So square root of 9x squared, square root of 9 is 3, square root of x squared is x. And then square root of 36, don't worry about the positive or negative there, we'll deal with that later. So square root of 36 is 6. And so basically what this is telling us is that if we factor this, we're going to have 3x, and here's where the negative comes in, and I'll show you why this is in a second when we verify. So basically we have 3x plus 6 and 3x minus 6 is going to be how we factor this out. Now I'll just really quickly go to a blank page here a second because I'm going to run out of space on this one to verify this solution. So if I verify, then basically I'll multiply these terms back out to see if it gives me what I should have according to the question. So 3x times 3x is 9x squared. 3x, so remember that you just have to multiply the first and then the outside terms. So 3x times by negative 6 gives us negative 18x. And then you do the inside terms, so positive 6 times by 3x gives us positive 18x. And then positive 6 times negative 6 gives us negative 36. And so basically what's going to happen is we're going to have 9x squared if we simplify this. Negative 18x plus 18x combines to make 0, so we have nothing there. And then minus 36 equals 0. So we end up with what we started with. So we know that we factored it correctly. And this is the clue to why these two-term equations are always going to have, like, they're going to be missing the x term in the middle. It's because if these two are perfect squares and you have a negative sign here, then that means you have to have a positive times by a negative. And because the other two terms are identical, they're going to always multiply to the same numbers, which are going to cancel out. So the middle two are always going to add up to 0. So you always have to factor into a bracket that has the two terms you square rooted these values to, and then one bracket always has to be a plus and one always has to be a minus. Okay, so 3x plus 6, 3x minus 6 is our factored term. And then the only other thing is we wanted to actually solve it by factoring. So again, I don't know, they didn't give you tons of space here, so I'll do it on this page. So if we want to factor 3x plus 6, we set it equal to 0, and then we need to start moving things away from this x to isolate it, right? So if we have plus 6 over here and we want to move it away, we need to subtract 6 from both sides. And 6 minus 6 is 0, so we're left with 3x on the left, and 0 minus 6 is negative 6 on the right. Then the only other thing we have left to do is right here we have 3 times by x, so we need to do the opposite operation to move it away, which is dividing, and we need to do that to the other side as well. So 3 divided by 3 is 1, and 1x is just x. Negative 6 divided by 3 is negative 2. Okay, so now I know one of my solutions is negative 2, and then for the other one it's going to be kind of the same thing, but so we have 3x minus 6 in this one equals 0. So this time we're going to have to add 6 to move it from this side. So negative 6 plus 6 is 0. So we have 3x is equal to 0 plus 6, which is 6. Again, we have 3 times by x, so in order to move that, we need to divide 3 out. 3 divided by 3 is 1x, which is just x. And then we needed to divide on the other side. 6 divided by 3 is positive 2. So now we have our two values, and then it says verify your solutions by substituting. So we can check and see if these will satisfy this equation by substituting those values in. So if we have x is equal to negative 2, we're going to have 9 times by negative 2 squared for x squared minus 36, and it should be equal to 0. Negative 2 times by negative 2 is positive 4. 4 times 9 is 36. 36 minus 36 is 0. So our verification proves that negative 2 would be a valid number. And then, of course, positive 2 squared is also going to be positive 4 times 9, which will be 36 minus 36. So that one works as well. Okay. All right, so with this one, it's the same setup, it's just set up a little bit differently. So you just have to recognize that you always have to set your equations equal to 0 before you can start factoring. So we need to move this 4 over to the other side, or the 49 over, but personally I would keep the x squared as my positive value. So if I have plus 4 here and I want to move it over to the other side, I have to subtract 4. And then that means I have to subtract 4 off the other side as well. 4 minus 4 is going to be 0, and on this side we're going to have 49x squared minus 4. Okay, so just keep in mind you can't combine these two because they're not like terms, right? This one doesn't have a variable attached to it. Okay, so now we have 49x squared minus 4, and you can see again that it's a two-term setup like this one. So then the first step should always be to check if these are perfect squares. 49, if we square root 49 and x squared, we end up with square root of 49 is 7, square root of x squared is 7. Or is x. And then square root of 4 is our other term. Square root of 4 is 2. So now we can say that what we would be looking for would be 7x. And remember, because you have this minus sign here, it's going to be 7x, your first term, plus 2. And then the exact same setup, but with a minus in there. And that's going to allow you to cancel out your x values that you would get when you multiplied it out. Okay, so I'm not going to run through this verification again, but you should run through the verification of the values. Oh, sorry, actually, we need to divide it out. So again, we're going to say 7x plus 2 is equal to 0. If we want to isolate the x, we're going to subtract 2 from both sides. 7x plus 2 minus 2 is 0. 0 minus 2 is negative 2. And then we have 7 times by x, so we want to move that away by dividing it. And then we have to do that to the other side as well. So now we're left with 7 divided by 7 is 1 times by x is x. And then we're left with negative 2 over 7. Okay, now in like a test situation, I would want you to show me both, but for this one, I'm just going to tell you that because we have the exact same setup, the other x value will be the same but positive, so 2 over 7. That'll save us some time on the video. Then you can substitute these values in. So you can use the very original equation. Sometimes this is the best way to do it because it will make sure that if you made an error with moving your number over, your answer will still verify correctly. So you use the very original equation, not the one that we modified here. So we want to see if 49 times by our x value is, let's do the positive one, let's say 2 over 7 squared, is that equal to 4? So if we go into our calculator, we should be able to do, let's see here, 49 times by 2 divided by 7 squared gives us 4. So we can verify that 2 over 7 will work. And then, of course, negative 2 over 7 squared is going to give you the same positive value, and so you're going to end up with the same verification. So that would be correct. Okay? All right, the next question that we were going to go over is number 6. So it says, determine the roots of this equation by factoring. So basically all you need to do here is, just like we did up here, remember your value, just like we did up here, remember your value always has to be set equal to 0. So with this one, we don't have either side equal to 0. So I want to move these things that are over here over to this side. I always like to keep my value that's attached, like my coefficient for the x squared value, positive. You should still get the correct answer even if you don't do it that way, but it's just my personal preference. So that means that in order to move this stuff over to this side, I'm going to say, well, if I have plus 0.125, I'm going to move it by subtracting 0.125x. And if I have plus 1.5, I'm going to move it by subtracting 1.5. Okay, and then that means I have to do the same thing to the other side. So negative 0.125x minus 1.5. Okay, and then, so 0.125 minus 1.25 is going to be 0. 1.5 minus 1.5 is going to be 0. And so we're going to be left with 0 is equal to 0.0625 x squared minus 0.125x, 125x, minus 1.5. Okay, so now what we want to do is see if we can get rid of this term in front of the x squared to simplify our equation. So because it's being multiplied, in order to remove it, we would need to divide. And if we divide it out of this term, we need to divide it out of every term. So we're going to divide this whole thing by 0.0625. Okay, so 0.625 divided by 0.625 is 1, so we're left with 1 times by x squared, which is just x squared, negative 0.125, so negative 0.125 divided by 0.0625 gives us negative 2. So we're going to do minus 2x, and then negative 1.5 divided by 0.0625 is going to give us negative 24. Okay, so now I have my new value. Because I've divided this out of every term, I don't need to account for it later on, and we'll look at a method in a couple of questions where you do need to account for the stuff you've divided out, because you don't do it equally to all terms, but when you've done it to all the terms, then you're good. You don't have to worry about this number again. So now what we do is we have this trinomial, right? We can say that it's equal to 0. So now you just want to factor it using kind of like your standard technique. So you want to look for two numbers that multiply to make negative 24 and add to make negative 2. So I did negative 6 times by 4 gives us negative 24, and negative 6 plus 4 gives us negative 2, which is what we wanted for this middle term, right? So that basically means that I can factor this into x minus 6 times by x plus 4. Okay, those are my two values, and they're set equal to 0. So it just says to determine the roots of the equation by factoring. So now what you would want to do is remember that the actual roots are going to have the opposite sign of this. So we're actually going to have x is equal to positive 6 and x is equal to negative 4. Okay, so the opposite. So basically what this is telling us is that we're going to have an x-intercept at positive 6 and an x-intercept at negative 4. Now, part of what you guys are required to be able to do is to verify your answer using graphing technology. So what you can do to make sure that this was correct is go into your calculator and type in, now for this one, for your y equals, you would have to put in the 0 equals in order to verify, because whenever you put in a y equals, it always has to be set equal to 0. So you're going to have to use this modified version that you did, not the original equation, to put it in your calculator. So it's going to be 0.0625x squared minus 0.125x minus 1.5. Okay, and then you can go to your graph. And what you will want to do is just check and see. Now with this particular one, I have my window set to standard settings, so if I wanted to, I could actually just count. I have 1, 2, 3, 4, and you can pretty much see that the graph crosses over at -4 there, which is what we said, so that's good. And then for this one, it's going to be 1, 2, 3, 4, 5, 6. +6, it crosses over. So you can just check. Of course, the other thing you can do is use your graphing calculator. So you'd go in and go 0, and then it's going to ask you left bound. So you would just want to go to the left side of the intercept that you're looking at and hit enter. Then it's going to ask you right bound. So you have to go to the right of the intercept, anywhere on the graph to the right, but make sure that you're like well enough past that you're for sure not on the intercept, otherwise it won't calculate it correctly. Then the last thing it'll ask you is guess, so you hit enter one more time, and it tells you that your 0 is when y equals 0, x equals -4, which is what we said here. So that's another way that you can verify if you don't want to count. The thing you have to be careful with about just counting on the screen is you need to make sure that you know that your window settings are set to like a scale of 1, right? And then you kind of need to know your window settings. So by counting those, I already knew that each one of these ticks has a value of just 1, so then counting to -4 would work. Sometimes your window scale might be set to something different, so it could be like each point is worth 2, and then you wouldn't be counting correctly, so you just need to be careful with that. Okay, so next question was, let me see here, number 6. Okay, number 8. Okay, so let's go over that one. So, I'm just gonna, sorry guys, I'm running out of space. This camera isn't, there we go. That might work a little better. Okay, so Govinda solved this equation. 15x squared plus x minus 2 equals 0. His solutions were -1/3 and x equals 2/5. Factor and solve the equation. So with this one, I'm going to show you a little bit of a different technique for doing this, which is called the swing method. And this can make... this is a useful method for when you have a question like this where you have a value in front of x squared, but if you were to try and divide this value out of, like, the coefficient for x here is 1, and we know that 1/15 isn't really any super great number, like it's not a nice easy whole number. And then same thing, like -2/15 isn't either. So it's not gonna, like if we divide out the 15 by all these terms, it's not gonna give us a nice easy set of values the way this one did, where you can find numbers easily that multiply to make the last number and add to make this one, right? Because they're gonna be weird decimals. So basically, if you come across a question like this, you can use something called the swing method. And what you do here is you would take let's see, how can I arrange this best? There we go. Okay, so what you can do is you can take this first number, and it's called the swing method because you're going to basically swing it over to the end by multiplying it. So we're going to take the 15 and multiply it by -2, and we're just going to straight out take it away from here and multiply it over. We're not doing the proper kind of algebra here like we did where we divided it out and we divided it by everything, so that canceled out the number. So you'll keep that in mind as we move forward. We're not properly removing this number from the equation, we're just moving it over, and so we're going to have to account for that later on in our math. So 15 times by -2 gives us -30, so we're going to be left with x squared because we've taken this over and multiplied it. The middle number always stays the same in this method, so x squared plus x. -2 times by 15 is -30 equals 0. So now we have an equation that is easier to factor, right? We have nice whole numbers. So what we want to look for is what are two numbers that multiply to make negative 30 and add to make positive 1, right? Because that's our invisible coefficient there. So the numbers that I chose were 5 and 6, right? And if we want it to add to positive 1, we need to have the greater number be positive. So we're going to do negative 5 times by 6 gives us negative 30. And negative 5 plus 6 gives us positive 1. Okay, so that's the values we are looking for, negative 30 and positive 1, so that's good. So these are going to be our factors. So you're just going to set up your brackets, x minus 5 times by x plus 6. Okay, those are our factors, but what you need to be careful for is, remember, we just moved this number around. We didn't use proper algebra to like take it completely out or to modify the rest of the equation, right? We just changed this value, and you can't do that in math, right? Because then you're just changing the whole equation. So the way that we account for this now is, because we used this to multiply out and find these two numbers, the 5 and the 6, we need to divide it out now to account for that change that we did earlier. So we basically need to go divided by 15 and divided by 15, because we got this number by multiplying by 15. So we need to divide it out. So basically what you would have here now is look for like a way that you can simplify this, right? So if we have x minus 5 over 15, the simplest version of this is going to be 5 goes into 5 once and 5 goes into 15 3 times, right? So we're just simplifying our fractions. Over on this side, we could do 6 doesn't go into 15, but we could do 3. So 3 goes into 6 twice. And it goes into 15, 3 goes into 15 5 times. Okay. Now, technically, if you want to make this multiply back out to the original equation, what you actually have to end up doing as well is to basically multiply your 15 back into the x for one of them as well. That's where it gets a little bit tricky. So really, if you wanted to multiply this out and have it end up being this original equation, you would have to go x minus 1/3 times by 15x plus 2 over 5. Okay, but don't worry too much about this right now, because all you need to worry about is what are the roots of this equation. And just by factoring like this, even without bumping that 15 back in front, we have our two roots. So we have negative 1/3, and remember that when we set that up as a root, it's going to be x equals positive 1/3, and then we have positive 2/5, so x equals negative 2/5. Okay. And so you can always double check of whether that actually worked by going in and doing your graph. So with this one, because your original equation was set equal to 0, you do want to use your original equation. Okay. You don't want to use the one that you modified here, because that's not going to give you a fully accurate answer, right? Especially if you made a mistake there. So we're going to go 15x squared plus x minus 2, and then we'll go to our graph. And then what we want to do, this one is pretty hard to see, especially because these are decimals. So what you might want to do, because what this is going to calculate is the decimal value, like if you try to do a trace. So you might want to just in your calculator do 1 divided by 3, which gives you 0.3 repeating, and negative 2 divided by 5 gives you negative 0.4. So those are the values that you should trace if you go in. So if you go in and do second function trace 0, and then again do left bound, so go to the left of your left intercept, or x-intercept, sorry, and then go to the right, make sure that you're past it, and then hit guess. We end up with negative 0.4, which was one of the solutions that we came up with, so that's good. Then you can go second function trace 0 to do the other one. So we want to be to the left of this positive intercept, which is here. And then right bound, you want to go past and hit enter, and then guess, and it gives you positive 0.3 repeating, which is what we had here. So we know that we solved our answers correctly. Okay, now the only other thing it says here is what error do you think Govinda made? So Govinda had negative 1/3, and we had positive 1/3, and then he had positive 2/5 and negative 2/5. So, you know, there's different ways that you could say that where this error happened. Like maybe he forgot that he had to add a positive one here, so maybe he mixed these up. Like he could have done positive 5 times negative 6, because that still would have multiplied to negative 30, but maybe he forgot about the adding. The other thing would be maybe he forgot that the root is always going to be the opposite of what you have in the brackets. So those are kind of some possibilities of where he could have made a mistake of having the incorrect positives and negatives, because his numbers were correct. Okay, last question here is number 9. Okay, so with number 9 it says a bus company charges $2 per ticket but wants to raise the price. So we have a daily revenue modeled. I'm just going to do this, flip this around so I have more space to work. Okay, so I'm going to start out by just writing out my formula. So we say r of x is equal to negative 30 x minus 6 squared plus 34,320. Okay, so x is the number of price increases, so pay attention to that because that'll be important later on. And r of x is the revenue in dollars. What should be the price per ticket if the bus company wants to collect daily revenue of 30,000? So what they're telling us is this value here, r of x, is going to be equal to 30,000. So we can rewrite our equation with the value substituted in here, because that's what we want it to be. Equals negative 30 x minus 6 squared plus 34,320. Okay, and because we're looking for the price per ticket and x represents the price increases starting at $2 per ticket, right? That's where they started at, and then we have a certain number of price increases. So if we want to figure out the ticket price, we need to know the number of increases that have happened from the original cost of $2. So basically we need to solve for x, and because there's no other variables in this equation, we can do that, right? There's only this one variable we need to solve for. So you just want to go through your proper algebra of rearranging this equation so that you start to isolate x. So the first thing you always want to start out with is adding or subtracting. So remember, basically, if you remember BEDMAS, brackets, exponents, division and multiplication, and adding and subtracting, the first thing you always want to do when you're using algebra to move things away is you basically want to do BEDMAS in reverse. So if there's anything that's being added or subtracted to the term with the variable, you want to do that first. Now keep in mind, brackets are going to be separate, so the addition or subtraction that's happening inside the brackets you don't count. So this is anything adding or subtracting outside the brackets. So we have plus 34,320, so we want to move it by doing the opposite operation. So if it's being added, we want to subtract 34,320, and then we have to do the same thing to the other side. So 34,320 minus 34,320 is 0. 30,000 minus 34,320 is going to give us negative 4,320. And that's going to be equal to, everything else on this side stays the same, negative 30 times by x minus 6 squared. Okay, the next thing we want to look at, so again, don't worry about anything inside the brackets here. The next thing we would look at moving backwards through BEDMAS is anything that's being divided or multiplied. Negative 30 is being multiplied by this set of brackets where our variable is, so we want to get rid of that by doing the opposite operation, which is to divide. And then that means we have to do it to the other side. Negative 4,320 divided by negative 30 gives us positive 144. Negative 30 divided by negative 30 gives us positive 1. So that is basically just x minus 6 squared. Okay, now what else do we need to look at? The next thing is exponents. So we have an exponent here outside the bracket and we want to get rid of it. What is the opposite operation of something being squared? Well, the opposite operation is to square root it, and then we have to do that to both sides. The square root of 144 is 12. And if you square root a squared bracket, you just end up with what's inside the bracket. So it's going to be x minus 6, right? Because the square root undoes this squaring. So now, sorry, mic just cut out. So now we have 12 equals x minus 6. The last thing, now that we have our brackets gone because we got rid of that exponent, now we want to go back to the beginning of the bedmass and start all over again with anything that's inside the bracket. So the first thing is going to be adding and subtracting. We have a 6 being subtracted, so the opposite operation to move it is to add 6, and of course we have to do that to the other side. 12 plus 6 gives us 18, which is equal to x. Okay, now what you have to be careful for here is don't think that that means that that's our price. Remember, 18 is the number of 15-cent price increases. So we need to figure out what is the total increase in price if you did 18 15-cent increases. So you would do 18 times by 15-cent. Personally, what I would do is just write it as $1. So if I change 15 cents into $1, it's $0.15. Remember, because there's 100 cents in $1, you would just go 15 divided by 100 if you weren't totally confident in that math. And then that'll give you your dollar value. So 18 times by 0.15 gives us 2.7. which basically means $2.70. And again, you have to be careful because you're not finished. Remember, that is the price increase. They want to know what is the what is the price of the ticket? Well, if we increased by $2.70, what was our base price? Well, it says that they were $2 and they're trying to raise the price. So they started off at $2 and now they're looking at a $2.70 price increase. And so their total cost of the ticket price should be $4.70. Okay, so it's a huge increase. So I'm not sure how well that'll work in real life. If you more than double your prices all of a sudden, there's a chance that people aren't going to want to pay that. But we don't have to worry about that in this question. Okay, so those are all of the questions from 7.2 that I was going to go over, and I hope that helped you.